Addition and subtraction of matrices. In this lesson, we will learn how to determine the order of a matrix and describe elements within a matrix, and then learn how to add or subtract matrices. To solve problems with multiple inputs, we can use a matrix, which is a rectangular array of numbers, like what you see here. These are the rows of a matrix. These are the set of numbers that are aligned horizontally. And then the column are the numbers here. This is the set of numbers that aligned vertically. Now, each number in a matrix is called the element or an element of a matrix. So each of the number here is an element of a matrix. Matrices, that's the plural of a matrix, are enclosed in this bracket here, in a square bracket. And this is usually named with capital letters. Now, moreover, a matrix is often referred to by its size or dimension. So when we say the size of a matrix, we will mention first the rows, the number of rows of a matrix. So we count the number of rows. So like for instance, in this case, we have 1, 2, 3, 3 rows. And then the second number you mentioned is the number of columns. So you have 1, 2, 3 columns in this case. So this matrix here has a dimension, a 3 by 3 dimension. 3 rows, 3 columns. Now the entries or the matrix elements are defined first by row and then by column. So for instance, if you want to locate the element in a matrix A identified as ij, we look first for the element in the row I and the column j. For instance, if you want to locate the element A sub 2, 3, that is the element on the second row. So 1, 2, it's on the second row, and this number here represents the column. So second row, third column. So it is this element here. Now we also have what we call a square matrix. It is called a square matrix because the number of rows and the number of columns are the same. So this is a matrix with dimension n by n. That means same number of rows and same number of columns. So an example of that will be a 3 by 3 matrix, 3 rows, 3 columns. 2 by 2 matrix, 2 rows, 2 columns. And we also have the row matrix. A row matrix is of this form, where we have a matrix consisting of one row only. So the dimension for a row matrix is 1 by n, 1 row, n columns. And then lastly, we have a column matrix. A column matrix is a matrix consisting of one column with dimension m rows, 1 column, so m by 1. Now, in terms of application, a matrix may be used to represent a system of equation. In this case, the numbers represents the coefficients of the variables in the system. And matrices often make solving systems of equations easier because they are not encumbered with variables. Now let's consider the example here. We are given here matrix M. We want to find the dimensions of matrix M. So to give the dimension, we count first the number of rows. So we have 1, 2, 3, 3 rows. And then the number of columns, 1, 2, 3, 3 columns. So this matrix here is of dimension 3 by 3. Next, let us identify the element A sub 2, 3. So A sub 2, 3 pertain to the entry on the second row. So this number here represents the number of row. So the second row and the number here pertains to the column, third column. So it is this number here. So number 6, that's the number or the entry on the second row, third column. Next, let's identify the element A sub 3, 2. So that means third row, this is the third row, second column, that's the column, second column. So it is this number here. Third row, it's on the third row and the second column. So that is 8. So now let's take a look at how we add or subtract matrices. We add or subtract matrices by adding or subtracting corresponding entries. So in order to do this, the elements of each matrix must correspond. Therefore, we can only add or subtract matrices with the same dimensions. So make sure that when you're adding two or subtracting two matrices, the two matrices should have the same dimension. Therefore, if you're given two matrices A and B of like dimensions, then addition and subtraction of A and B will produce matrix C or matrix D, in this case, with the same dimension. And how do you do that? You add, or how do you get the sum of the matrices? You just add corresponding entries. So you would add the ijth entry in matrix A to the ijth entry in matrix B. And that will give you the ijth entry in matrix C. Similarly, when you're subtracting two matrices, you do the same thing. You subtract corresponding entries. So you subtract A sub ij, the ijth entry in matrix A. You subtract that by the ijth entry in matrix B. And the result is the ijth entry in matrix D. And also the commutative and associative property of addition holds in matrices. So addition and subtraction of matrices is commutative and associative. Commutative, that means the order does not matter. A plus B is equal to B plus A. Associative, meaning the grouping does not matter. So if you add first A and B and then you add C, you get the same result when you add B and C first, then add the matrix to A. So to illustrate addition of matrices, we take a look at this example. Suppose you're given matrix A here with these entries and matrix B with this entry. To add A and B, so to add matrix A and matrix B, you just add corresponding entries. So this row here is equal to the sum of A and E. And then this entry here is equal to the sum of the entries here. So B plus F. And this entry here pertains to the sum of C and G. And the entry here pertains to the sum of D and H. For example, we're given here matrices A and B, and we want to compute for A plus B. So A plus B is equal to the matrix. The matrix A plus B will also be the same, will also have the same dimension as matrix A and B. Note that matrix A and B have the same dimension. So again, before you can add or subtract matrices, you make sure that both matrices are of the same dimension. So in this case, matrix A is 2 by 2 and matrix B is also 2 by 2. So the sum of these two matrices is also a 2 by 2 matrix. Now let's take a look at the elements of the sum of the two matrices, A plus B. So the first row, first column entry is equal to 4 plus 5. So that is 4 plus 5. And then the first row, second column entry is equal to this element plus this element. So negative 2 plus 3. And then the second row, first column entry is 0 plus negative 2. So 0 plus negative 2, or same as 0 minus 2. And then 1 plus 7 for the entry here. So 1 plus 7. Again, you add corresponding entries. So therefore, we have 9, 1, negative 2, 8. This is the sum. This matrix here is the sum of matrix A and B. Another example, given matrices A and B below, find the sum A plus B. Before finding the sum, we make sure that both matrices have the same dimension. The dimension of matrix A is 2 by 3. And matrix B is also 2 by 3. So both of them are 2 by 3 matrices. So let's get the sum. So to get the sum, A plus B, you just add the corresponding entries. So you have 7 plus 13. 7 plus 13. And then 1 plus 4. 1 plus 4. 1 plus 2. 1 plus 2. So these are the entries on your first row. Second row would be 0 plus 2. 0 plus 2. And then negative 1 plus 1. Then 6 plus negative 5. Then you simplify. So the sum is equal to, so 7 plus 13 is 20, 1 plus 4 is 5, 1 plus 2 is 3, and 0 plus 2 is 2, negative 1 plus 1 is 0, 6 plus negative 5 is 1. So we have this matrix here, also a 2 by 3 matrix, and that is the sum of the matrices here. Next, let's find the difference. The difference of the two matrices, A minus B. So to get the difference, you just subtract corresponding entries. So you subtract 7, so A minus 13. So you have 7 minus 13, A minus B. So you get A first and then minus the entries in B, from B. And then 1 minus 4, 1 minus 2. Then you have 0 minus 2, negative 1 minus 1, and 6 minus negative 5. And then you simplify. So 7 minus 13 is equal to negative 6. And then 1 minus 4 is negative 3. 1 minus 2 is negative 1. 0 minus 2 is negative 2. Negative 1 minus 1 is negative 2. And 6 minus negative 5 is 11. So this matrix here is this matrix here, the difference of matrix A and matrix B. Now let's have this example here. Given matrix B, then we answer the following question. What is the order of the given matrix here? So you count the number of rows. So we have 2 rows, 2 columns. So this is a 2 by 2 matrix. Then what is the element of B sub 1, 2? 1 means the row 1, second column. Row 1, second column. That is 0. That's the entry 0. And the element B sub 2, 1 means second row, first column. That is 2. And what type of matrix is this matrix, matrix B? This is a square matrix. Another example. Given matrix C here, answer the following questions. What is the order of this matrix? Order means you count the number of rows and then the number of columns. We only have one row, so it is 1 by number of columns. 1, 2, 3. This is a 1 by 3 matrix. And what is the element of 1, 2? C sub 1, 2. So that pertains to row 1, second column. That is the element 0. What is the element C11? C11. So that means first row, first column. That is the entry 1. And what type of matrix is C? This is a row matrix. Now, given matrices A and B below, find the sum of the two matrices. To get the sum, you make sure first that the two matrices have the same dimension. Both of these matrices are of dimension 3 by 3. 3 rows, 3 columns. 3 rows, 3 columns. So both of them are 3 by 3 matrices. So the sum is just, when you get the sum, you just add corresponding entries. So you have 3 plus negative 2. And 2 plus negative 2. And then 1 plus negative 1. For the second row, we have 5 plus negative 5. And 3 plus negative 2. And then 4 plus, so 4 plus negative 4. Then 7 plus negative 7. And then negative 6 plus 6. And then 2 plus negative 1. And then you simplify. 2 plus negative 3 plus negative 2 is 1. This is equal to 0, and this is also equal to 0. This 0, this is equal to 1, and this is 0. So 0, 1, 0. So if you simplify this, you have 0, and this is also 0, and this is 1. So this is the sum of the two matrices. We have a special term for this matrix. This is actually an identity matrix. That is just extra. Now let's find the difference. A minus B. The same thing. You subtract corresponding entries. So that means you have 3 minus negative 2, 2 minus negative 2, and 1 minus negative 1. Then you have 5 minus negative 5. And then 3 minus negative 2. And then 4 minus negative 4. 7 minus negative 7. Negative 6 minus 6. And 2 minus negative 1. Then you simplify. So 3 minus negative 2 is 5. 2 minus negative 2 is 4. 1 minus negative 1 is 2. 5 minus negative 5 is 10. 3 minus negative 2 is 5. And 4 minus negative 4 is 8. Then simplify this. 7 minus negative 7 is 14. Negative 6 minus 6 is negative 12. And 2 minus negative 1 is 3. This matrix here is the difference of the two matrices here.